Welcome to the Network Engineering Video Blog. I'm your host, Michael Crane. Well, today we're going to cover Cisco to Juniper lag testing. We set the lag up in a previous video, and we're going to be using the Xena compact gigabit test set to do the testing with. Here's the specification on it, 802.3 AD. And I wrote what our goals are for today, and so I didn't miss them. I'm going to try to do this video in 30 minutes so we can get through this testing without a lot of repeating of what I did in previous videos. So today in this video we're going to go over the test bed. This is our test bed. We'll look at the network drawing briefly just to remind ourselves where we're going with this. What our testing goals are, and then we'll provision the Juniper and the Cisco, and then we'll set up the Xena test set and do some testing. So first, let's look at the test bed quickly. So here's the Xena, here's the Cisco Ethernet switch, here's the Juniper, and here's the Xena. And these two Xenas are actually the same box. Just for the drawing, it's easier to split it apart like that. But it's on ports 1, 2, and 3 on this side. I mean, sorry, it's actually wrong. It's actually 0, 1, and 2, and then this will be port 3. And I'll fix that here in a minute. I'll just do it right now, actually. 0, 1, and 2. Okay. Here's the IP addresses on this side, .11.12.13. A bunch of port assignments and that sort of stuff. I can post this picture on the in the comments if people are interested in the details of the port assignments. This is mainly just for your information, so when we're going through the testing, you can kind of look at it and or at least you'll know what I'm doing here. And yeah, so then it's going to be on lag 2, VLAN 11. And on the Juniper is called AE2, which is aggregated Ethernet, I think. And then here's the network it's in. So that's a quick look at the test bed. Now, what our goals are for today. And like I said, this is going to be quick, so I'm just going to read you the goals. I think last time we put together a little test plan. We're just going to play around with it, do a quick sanity check, and then be done with it, okay? So our testing goals are going to be load balancing to make sure it's going to load balance properly over all 3 links in the lag. We're going to do a little bit of capacity testing to make sure we're getting close to our 300 meg capacity out of our leg. We got 3 100 meg links, and then we'll do a quick failover testing, which is basically just, we'll pull one of the cables and make sure the traffic gets moved over to the other links and not just completely dropped. Okay, and that's about it. So let's get started. Okay, so let's take a quick look at our network drawing. I went ahead and pulled it up, and in the last video, or a previous video, not the last one, we provisioned these 3 links for the lag, and we did a quick ping test after we were done. And I don't know if you remember, they were grayed out, and I've now blackened them in since they are provisioned now. Okay, and here's the test bed. And so basically, where these servers are, this .16, 17, and 18, they're going to be going. They're going to be in ports 0 through 2 in the Xena test set, and then this port on the top of the Juniper right here, okay, it's going to be going into port 3 of the Xena test set. Okay, so let me pull up the, I got a snapshot of this, our layout. Yeah, so port 0, 1, and 2 on this side right here is going to be going into these ports right here. And then this port 3 will be going into the Juniper GigE port right here. And it's going to have an IP address of .162. Okay, so the next thing on our hit list is to do some provisioning. So we'll start on the Juniper side, and let's see, first thing we want to do is monitor start messages. Oops, start, if I can spell it, messages. And I'm already monitoring them. So we're going to do, before we do anything, you always want to remember to do a show config. So it's just show config. And then copy all this to the clipboard and paste it into your favorite notepad. And it's actually show config on both the, of course, you got to spell it right, on both the Cisco and the Juniper. So that is one of the few commands that's easy to remember. As you can see, to save some time, I've already done it for us, so we don't have to mess around with that. And okay, so looking at our drawing here, we're going to be doing the Juniper side. It's .161. It's missing the net mask, and the net mask we're going to give it, it needs to be in a separate network than this 192.168 .11.x/16. So we're going to put it, we're just going to use 4 IP addresses because this is point to point. So what we're going to do is we're going to make this 192.168.11.161, and it's going to be /30. Now this is on the Juniper side, and on the Xena side it'll be 162/30. But we'll look at that later. And by the way, in case you don't remember, if you want to, it's 255.255.255.252. That's the equivalent of /30. The Juniper only accepts a /30 right here, so we're just going to use /30. Okay? So, all right. That's, we're doing GigE 000. I know, I apologize, that's kind of hard to read right there. So it's config, and it's set interfaces GigE. It's 0/0/0. Unit 0, family inet, and its address is 192.168.11.161/30. And okay, we'll commit that. Oh, there we go. So let's do a show, and there it is. Okay, very good. So let's see, let's go through these real quick. Oh, well, that's it for the Juniper side. I guess next is the Cisco side. So what are we doing here on the Cisco? We've got ports 10, 11, 12, and 13. Interface, range, fast, 10, 11 through 13. All right. And let me go over here to my config. We don't need to do much really on the Cisco, I don't think, because we did this in a previous video. There is one thing I want to change this description a little bit. Then we need to do a no-shut on them. It's about really the only two things that we need to do on it. So okay, so let's do a description. And we're going to say to Juniper, oops, if I can spell it, Juniper M5 and 192.168.11.x/16. Okay, and I wanted to add the network on there because it makes it easier when you're looking through the Cisco config to know what the IP address is. You got everything else here. You got the VLAN and all this other stuff, but you don't know what network it is. So we're gonna add that description, and we're also gonna do a no shut on it. All right, and I'm gonna Control C and do a write. Okay, so let's start doing some testing. So the first thing I want to mention is I changed the IP addresses on our drawing. I had .11, .12, and .13. I'm not exactly sure what orifice I pulled those numbers out of, but anyway, it should be .16, .17, and .18, which if you were paying attention to the network drawing, that's how they were laid out on that. So I went ahead and updated those. And I've also went ahead and loaded all the port configurations up from the previous video that I did, which was blog number 37, which showed how to provision the UDP and basically set up the Xena. So I'm not going to go through that again. If you need to learn how to do that, you can go watch that blog. It's very long and detailed. Also, I on blog 41, I also showed adding all these ARP streams in to keep the address, the MAC address lookup table from aging out in the Ethernet switch and in the router. So that was in blog 41 if you want to go check that out. I put together this little test document. This is what I'm going to be using. I do this all the time when I'm going to do a test. And it's just commands that I'm going to use. So we're going to look at the load balancing from the 3750 side. We're going to look at it from the router side. And if you look at these commands, I kind of put them together. It's a mixture of pipes and ORs and regular expressions. And if you want more information on how to build these, just leave a comment in the comments and I can go over them. Or if you want these commands, I can put them in the comments as well. Just let me know. So it's going to be off to the side over here. I'm going to copy and paste these commands in whenever we're looking at stuff. So, okay. Testing. So, first thing we want to do is we want to enable all the ARPs. So make sure all your ARPs are enabled. All right. And then you want all your streams suppressed. Not disabled, because you won't be able to go from disabled to enabled when the ports are running. If you go to the global stats area, you can start the traffic on everything. This works much better than this up here. I don't know why. So we're going to start the traffic, and really right now the only thing that should be running are our ARPs. And as you can see, we're not seeing any stats on that. And that's because when we set them up, the streams, the ARP streams, we set the test ID. We basically just deleted it out. So here's one of the ARP streams, and you can see the test ID is blank. Okay, and that's also in blog 41, I believe, where I talked about zeroing that thing out so it doesn't show up on your global stats. All right. Okay, so the first test we're going to do, and I am hesitant about going through this again. We know this is going to fail. This is load balancing testing on the Cisco 3750 side, and in blog 41, I already showed that this is not going to work. But we'll go ahead and do it real quick anyway. I'm going to go through it pretty quick, so hold on to your hats. I'm going to go ahead and we'll check the interfaces real quick. Okay, this is a Cisco down in the bottom. And you can see it's basically idle. You're seeing the ARPs and other stuff in there, other management traffic. So, okay, I'm going to go ahead and go to the stream configuration. I'm going to start one of the streams to enabled. And this is going from port 0 on our port 0 here to port 3, basically. All right. And so go look at these stats real quick. These Cisco stats, by the way, take 30 seconds to update. So you'll notice that these numbers aren't going to be right. So this top set of numbers right here are the inbound. I know it says 6 meg, but it'll catch up. It'll eventually be 10 meg. But what we want to note is what lag trunk it put it on. And 41 through 43 are the lag trunks. 11 through 13 are the access side, right? Okay, so it put it on 42, and we could verify that in Juniper, but it's not necessary because they're physically cabled together. So let's go to the global stats here, and we can see that right up here there's no errors, right? And we're transmitting about 10 meg, and we're receiving about 10 meg. Okay, not very exciting, and we'll look at this latency and jitter stuff later, but it's very low. This is in nanoseconds, by the way, if you're wondering why that number is so big. Oh, and if you're wondering why I'm using just 10 megs per stream, that's set right here in this rate, is I don't want the system under test to start queuing or do anything weird with it while we're testing load balancing, because that's not the goal of this test. Let's fire up another stream. We'll go down here to stream 2, enable, and that is for you guys following along at home. That's this port right here, sending it to port 3, of course. And let's go look at our stats. Yep, so you can see here's port 2 right here. It's catching up. And it put it on the 3rd lag link. Okay, so we've got one on the 2nd one. Now running 10 meg, one on the 3rd one. It'll eventually, the stats will eventually catch up and say 10 meg. Let's go look at our test set. Yep, transmitting 10 meg and receiving 10 meg. Life is good, no errors. Everything's hunky-dory. Okay, so let's go over here to stream config. We'll go ahead and fire up the last one. Here, enable. So this is on port 3, or I'm sorry, well, it's our 3rd access side. So it's this guy right here. Okay. I'll fire them up. Clear these out. Copy and paste our commands in here. And as you can see, so he's firing up. Yeah, the stats haven't caught up yet. And of course he's failing because instead of putting it on the 1st lag link, which has hardly any traffic at all on it, it put it on the 3rd link, which is not a problem when you're only running 10 meg streams, because these are 100 meg ports. So everything should be running just fine. We'll go look at the stats. Yep, everybody's transmitting 10 meg. Oop, that's receiving. Everybody's transmitting 10 megabits per second. Everybody's receiving 10 megabits per second. We have 0 errors. And, you know, this thing's idling. It's not doing anything. Yeah, I know these numbers look big, but that's in nanoseconds. It's actually 0.174 milliseconds, which is pretty small, which it should be. Okay, so we know that failed, and we expected it to fail. I We've already done this in a previous video, like I mentioned. So, let's see here. I'm going to go ahead and stop all the traffic. Go back over here to the configuration, stream configuration grid, and suppress all the streams. Oop, that's already suppressed. Okay. And I didn't have to actually stop the traffic to do that, but I did. It clears the counters out and all that other fun stuff. I'm looking at our test. So that was the 3750 load balancing test, and we knew that was going to fail. So this is the one we're interested in, the Juniper lag load balancing. Now, if you watched that previous video on Cisco to Cisco, the Cisco 3845 passed this test with flying colors. It load balanced perfectly. It put each 10 meg stream on different lag trunks. Okay, so we're hopeful that Juniper will behave the same way. All right, so looking at our drawing now, what we're going to do is we're going to initiate streams from this side, port 3, and terminate them on each one of these ports down here. So what we're going to do now is we're going to do, first we got to go over here and start all our traffic. Okay, all our stats are cleared. Go to the stream configuration, and let's make sure that these counters aren't showing anything funny. Okay, so here's the Gig E port. This will be the inbound side. And then these three down here, the FE ports of the fast Ethernet lag ports. And there's some management traffic and ARPs and stuff going on there. Just ignore the little small numbers. So, okay. So let's go ahead and enable him. And I'll check our stats. Yep, we're getting traffic. We're transmitting about 10 meg per second. And we're receiving 10 meg per second. We have 0 errors. Let's go see where he put them. And let's see. So this is the input, which is 10 megs. And he put them... oh, here it is. Output. Put them on the second lag link. Huh, interesting. Just like the Cisco started out when we tested that. Huh, I wonder why. So, okay. That's good. Let's go back to our stream configuration. Start our second one. Go to our global stats. Yep. He's transmitting 10 meg. Receiving 10 meg. And let's go see where he put them. And, okay, so we got our input rate is about 20 meg. And then we've got one on the second one and one on the third one, which is exactly what 3750 did. Let's go for the big money shot and stream configuration. I'll enable the third one. Look at our stats. Yep, transmitting 10 meg, receiving 10 meg, and you can kind of see so everything's starting from port 3. There's the different streams. It's terminating on port 0, 1, and 2 on the test set. So that's all good. And let's go see where he put them. And okay, so we're inbound 30 meg about. And well, that's a little different anyway. It's now he's got 20 meg on the first link, where the Cisco had doubled it up on the third link, I think. So that's, I call that a fail. Why does it not use the link that has the least amount of traffic on there? I don't know. And when they're 10 meg, like I said, it doesn't matter. I mean, there's plenty of bandwidth on there to handle 20 megs worth of traffic. But so I chalked that up to, well, let's wait and see when we do some capacity testing. If it does this with big streams, then it's going to fail. In my book, it kind of failed already because I don't know why in the world some developer thought it was a really good idea to just not put evenly space out the traffic. It just boggles my mind. Okay, so for the next test in our hit list here is we're going to look at the lag queuing with normal traffic, and normal being this 10 meg stuff, right? So what I'm going to do is I'm going to leave all the traffic that we had running. We're going to go over to the stream configuration. I'm just going to enable everything. Okay, so now we've got basically 30 meg of traffic, full duplex. And what we're looking for is we're looking for the queues. And I'm going to look at this latency real quick. So this is port 3, it looks like. The source port, so we're getting a little bit of a receive latency on port 3. Not much on the other ports. And the jitter doesn't look like much of anything. Kind of bounces around, but like, you have to remember, these are in nanoseconds. So this is micro tiny. Right? So, okay. So we got those running. We'll go look at the Cisco side real quick. And yeah, it's not doing anything. You can see it's the input queue size is 0, max is 75, drops 0, flush is 0. And normally what I've seen in my past experiences is you'll start seeing these flushes. But since we're not getting any errors, I knew this was all going to be 0. So let's go take a look at the Juniper side. All right. And these are best effort queues because we're using UDP. We don't have any class of service tagged on them. And as you can see here, the ingress queue, you see right here, so it's porting class, best effort, ingress. I see, I'm not too worried about this. I think that's a cumulative counter. But it looks like it's queuing basically all 30 meg. And this is, and I'm looking at the queue going into the lag. And so it's basically, looks like queuing everything. And that's the egress side, right? But if we look down here, it doesn't really seem to have any kind of effect on the average latency. So I'm not too worried about it. So that's okay. I mean, everything seems to be working okay. And by the way, if you're wondering about the egress side of the lag, I just thought about this. From the Juniper's point of view, that's this guy right here. If you go in this direction, out of the lag. Okay. Another thing I wanted to point out too is, so the ingress side of the lag, which is this data up here, is not queuing anything. And I find that quite interesting. So it's it's got a big queue of stuff sending out of the lag, but not one going in. I find that quite interesting. I don't really understand it. I would have thought there would have been something, but well, you know, you can see the Cisco down here. It's just idling. This is nothing for the Cisco, and it's actually nothing for the Juniper either. It's just, I'm just surprised that number is so big in a queue. But you can look at the stats, and this is the inbound. So this is receive latency up here, right? And here's your ports 0, 1, and 2, which is would be the receiving from the Juniper onto the Cisco side, and you can see that the average latency is puny. Okay, so I'm going to go ahead and stop all this traffic. Come back over here to the stream configuration. I'm basically going to suppress all the streams. Now what I'm going to do is I'm going to bump the traffic coming from this port right here to 75 megs per stream. So we'll have 3 megs at 75 megs. And you remember this failed because it first it put it on this port, then it put it on that port, but it put 2 of them on this port. And at 10 megs per stream, that's not that big of a deal. But at 75 megs per stream, if it does this, we're going to have problems, right? So let's see what happens. Okay, so I'm going to go ahead and bump these up to 75 megs each. Well, it says 74, so close enough. And let's go ahead and go up here and start the traffic. Okay. Let's check our stats real quick. Yep, all our stats. There's no traffic except some management stuff. Let's go over to stream config and let's start one of our streams. Okay. Okay, you can see it's got about 73 meg coming in on the Gigi, and it put it on, again, the second link. All right. And let's go look at our stats, make sure everything's good there. No errors. Transmitting about 75 meg. We're receiving about 75 meg. That's all good. So let's go ahead and start another stream. See where he put them. Okay, so we got about 140, basically almost 150 meg coming in on Gigi port. He's got 1 stream on second one on the third. Oh, this is not looking good. Okay, let's go check our stats. So we're transmitting about 75 meg on each stream, and we're receiving about 75 meg. Okay, good. And our latency is 0.277. That's good. I think that was about what it was with the 10 meg traffic. So there you go. Okay, here's the big one. Will it or will it not behave itself? Okay, so he enabled it. The third stream. Let's go see where he put them. He says about 219 meg ingress from the Gigi. But look at this. So he's trying to load up. So he's got 73 meg on the third lag, and he's maxed out the second link in the lag, and as you can see, the first link is doing nothing, and that's not acceptable. So let's look at the stats. Oh yeah, see all the errors we're getting. So yeah, we're dropping. Our latency has gone through the ceiling. Our jitter is surprisingly not as bad as I thought it was, but yeah, this is bad. So I would call the load balancing for sure failed, and I am. These guys Juniper must have bought the same chipset that the Catalyst people did, because this is just horrible. Okay, so last thing I'm going to do is I'm going to stop all this traffic, and I'm going to go ahead and I'm going to enable everything. Enable. I'm going to change the bandwidth back to these to 10 meg. And what I'm going to do is, in case you're wondering if link 1 actually works, these guys need an enter button, something fierce. This is driving me nuts. Anyway, I'm going to go ahead and enable everything. This is back to our 10 megs per stream, 30 megs duplex. And what we're going to do is a quick failover test. I'm basically going to start pulling cables out of the routers, the links on the lag one at a time, and basically I'm going to force the traffic onto the first port to see if it actually passes traffic, which I am pretty sure it will. So one of the things we want to do is I'm going to monitor, start messages, and on Cisco it's a term debug. This it's term monitor, and this way you guys can watch as I pull the links out. The console messages say that the link has gone down. Okay, so I'm going to go over here. I'm going to start the traffic again. And everything should be hunky-dory. We got 0 errors. Everybody's transmitting 10 meg, and everybody's receiving 10 meg, approximately. And the average latency is about what we got last time, and the jitter is very low. Okay, so let's go see where I put all the traffic. Okay, so we've got 30 meg coming in on the Gig E side. Just to refresh your memory, that's right here. 30 meg going this way, right? And he's got looks like 20 meg on the second interface, 10 meg on the third interface, and on the inbound side, look at, no one is using the first interface. That is kind of interesting. So the input rate is, so he's got 10 meg though coming this way, and 20 meg coming this way from the Cisco. So that's just completely bizarre. So okay, let's see if we can force the traffic on there. I'm going to go pull a link. Okay, so I pulled the third link in the lag, and let's go see what happened. And so we dropped about 800 packets. That's not that big of a deal, but everybody seems to be recovering okay. But the big question is, where did he put it? And look at that. He dumped. Wow. So now the Juniper, this is bizarre. So now the Juniper is sending all 30 meg this way to link 1 on the output, and the Cisco is at least split it up. So he's put it looks like 20 meg on the first one. So we've got 20 meg going this way, and he put 10 meg on the second down here. That is truly bizarre. But as you can see, there is nothing wrong with the first link. They just, for some reason, don't want to use it. So okay, let's see what happens when I plug it back in. All right, plugged it back in. Not really much of an error change. Let's see what happened. Okay. Look, it's moved. They have moved everything back off those links. Back off that first link. I am truly baffled. I don't know if this is an LACP thing or what's going on. And one other thing I want to mention is I'm probably not going to try to fix this, because the 3750 has got the Cisco WAD that I talked about in video 41. Trying to fix it from the Juniper side would be kind of pointless. I also think that both of them would work just fine if I was using a bunch of small pipes. So instead of running 3 75 meg streams, if I ran, I don't know, 50 3 meg streams, then it would probably load balance just fine. So and so with that, I've decided I'm not going to mess with it anymore. Also, if someone knows the fix for this on the Juniper side, please leave it in the comments below. Oh, one last thing. I wanted to point out that if you have the opportunity to either put a bigger pipe in or use a lag, use a bigger pipe. That is my final word of the day, because lags are a headache, even though they're still quite used. So I will leave it at that, and if you want to see me dig into this further and see if we can make it a little better, leave a comment in the comments. If you like this video, give it a big thumbs up, and if you have any questions or comments, leave them in the comments below. I'll see you next time.